Hi everyone, I'm Rinto. Today I want to show a new video on how I do my 3D models and optimize it using my own self-made optimizer tool. So firstly, let me generate my 3D model which I'm going to use for this demonstration. As I previously shown in my previous video how to generate my 3D model, so I'm going to use the same steps here. Once the model is generated, we'll proceed with our optimization. I will make this part to run a bit faster, as we already know how things works in this optimization model. So our model is ready. Now we can see all our numbers are failing. So let me use my optimization tool and let's sketch on how we proceed with our optimization. So this is the optimization tool and it has a bunch of inputs that we need to input so that the tool can proceed with the optimization. So let me first select a frame that I want to optimize. Since all my frames here have equal base spacing, I will take a single frame and I will proceed optimization of this single frame so that I can replicate the section size to the other frames also. So let me get the member numbers. So now let me start filling the inputs. So what the inputs basically do is, so I'm telling the tool to use sections between 250 mm depth to 1500 mm and flange width starting from 1150 and to 600, and the web shall increase at a rate of 50 mm and flange width shall increase at a rate of 25 mm. And then I have controls for web depth to web thickness, flange width to flange thickness, web depth to flange width thickness also, and then we'll enter the flange thicknesses that we want to use for this model. Then we are entering the location of the staad file so that our tool shall know which model to be optimized. So once the directory is also filled, then the next step will be splice control. Let me fill the directory. So now it's time for splice control. So what a splice control basically means is that whenever we do a section, we want to mention where the moment splice or the end plate splices are going to come. So in between the splices, we usually keep our flange widths to be same. So the splice control also does the same thing. So whatever you separate within the square brackets, those will have same flange widths, and our tool will only vary the thickness of the flanges to get the optimized section. So in this case, I'm giving 81 and 82 a single section, and 83 to 87 I will have one single piece, and then 88, 89 another single piece. Similarly for the others too. So once having done my splice control, it's time for me to tell my tool to do the optimization on which code, because optimization can be either with 2005, 2010 or 2016 as per American. So we can check in our below parameter, it is 2005. So I will check the 2005 AIC 2005, and now that everything is done, let's check the utilization ratios. So everything is failing. Let me select all those numbers and I will give optimize. So once we click the optimize, our tool will start running. So I have increased the portion of this optimization process so that you don't have to wait for the complete thing. So the tool does a certain number of iterations to arrive at the optimization. So once it has arrived at the optimization, it will stop the iterations and it will give our final section. So let's wait for the iteration to complete. So now the iterations are over and the number that you are given has completed optimization. So let's check how the ratios has come. So everything is optimized. So now let's check the flange width. So for the 82 we had given a single piece, it had a flange width of 175, and for 83 to 87 we had given another single splice. So everything has a flange width of same 150, but it is varying the thicknesses to get the optimized product. Similarly for 87 also we are having but the thickness is 8, and then 88, 89 is another single piece and it is also using 150, since 150 gives the optimized section. So we are doing the one frame. So since we have all the base spacings are equal, we can replicate the size of the same frame to everything. Now what we have left is the last frame, and the last frame will have a tributary of half the tributary, so that portion needs to be optimized. So now we can see most of the rafters are failing. Let me get that separately. You can see the rafters are all failing, so let us select those members and let's put it into the optimization tool and let's see how it goes. So like before, I'm going to update the members places. So the advantage of the tool is that once you are given everything, the optimization part will be taken by the tool and you don't have to do anything. All you have to do is finally check if everything is as per your requirement, and then you can use the model for the further process. So we have entered for the rafters. I will add the columns also, and from the last frame to this frame we have one minor difference, that is this frame has wind columns too. So let's add the member size of the wind columns too in the splice control. So 166, 167, 168, and the final two numbers are 169 and 170. So the code will be 2005. Now that you have entered everything, let's select all those members and we'll give optimize. Once we give optimize, our tool will begin the process of optimization. So until then, let's wait. So like before, this will also do a certain number of iterations to arrive at the optimum section. Usually the iterations only somewhere between 3 or 5 iterations. If it is getting optimized even before that, then it will stop even at the first or second iteration itself. So now that the iteration is done, let's replicate the values of all those frames to wherever required. So I'm taking the first frame that we optimized and I'm going to update those sections to the other frames which are of the same tributary. So let's say if you have like 2 or 3 frames of different tributaries, then we will have to optimize those sections like we did for the previous both frames, and then we'll have to replicate those sections to the other frames which have the same tributaries. So now the first frames which I made, I'm replicating everything, so it's almost done. So now I'll have to replicate the sections for the end frames also. So I'll take those two separately and I'll do the same process again. So now that I have replicated everything, now I will just run a final analysis. So how much time did I take for to complete a single 3D file? If you want to check it, there is timestamp at the bottom of my screen. Then you can check the start time when I started and the end time when I finished. So it hardly took me around somewhere between 40 to 45 minutes to complete one 3D model. So there you go, everything is perfect. So if you guys find this video interesting, then feel free to like, subscribe and share. Do follow the channel for some interesting optimizations. Thank you.